Okay, the back of the worksheet, there's only 3 problems, and these are all series parallel combination problems. Now, if you look on the bottom, it says work number 2 first, because that's the easiest, then number 3, that's the second easiest, and number 1 last, because that's the most difficult. But I'll do number 1. Number 8. Oh, I wrote the wrong numbers. It should be 9, 10, and then 8. Alright, now the first thing we're going to do is we're going to redraw that schematic diagram. And we're going to redraw it because we use all of our diagrams, all of our schematics to figure out different stuff. So this is number 8 on the back. So R1 is 1 ohm, R2 is 3 ohms, R3 is 10 ohms, R4 is 5 ohms, and R5 is equal to 0.05 ohms. And they tell us that V3 is equal to V3 is equal to 30 volts. So they don't tell us the voltage of the source. Well, whenever I see that I have 2 things, I'm going to use Ohm's law. So when I say 2 things, you know that when we do circuits, we use Ohm's law over and over and over and over again. So here, I see that I have R and I have V. So Ohm's law says that V is equal to IR. I can apply it to just this one branch, so V3 is equal to I3 times R3, so I3 is equal to V3 over R3, which is 30 volts divided by 10 ohms, which is 3 amps. So what I know is the current here, I3, is 3 amps. Now, depending upon how I want to do this, because I'm given all the resistances, can I still find an equivalent resistance like we did in the other problems? Yeah. So I could start going back and filling in certain things, but you know what I want to do in this problem is I want to find everything. Okay. Now, let's say I had a problem where I'm not given all the resistances. If this is 3 amps, now let's look at how do I know whether something's in series or parallel? It has to do with the total current coming out of the battery. Okay? The total current coming out of the battery. What I'll do is, right now, I'll just go and find my equivalent resistance, and then I'll go backwards and go with what they told me. So, coming out of the battery, I have my total. It goes through here, but at this point, it splits. Part of it goes here, and part of it goes here. Now, what I notice is these 2 are not in parallel. How do I know? Because there's these other resistors in between. So, the same current that's flowing through this resistor is flowing through this resistor, is flowing through that. Remember, think about water flowing through a pipe. Whatever's going through this one is the same as this, so that means these 3 are in series. If they're in series, that means the current across here is the same, because in series the current's the same. You see how you can already start figuring stuff out? And then I can use Ohm's law here, and I can say, you know, V is equal to IR, and this voltage drop is equal to IR, which is 5 times 3, which is, so V4 is equal to 15 volts, and V2 is equal to 9 volts. But I already started doing stuff, and I don't have a way to check my work, so that's why I'm going to start doing my equivalent resistances. Okay? So these three are in series. So the first thing I'm going to do is I'm going to redraw my diagram. And I'm going to leave everything the same, but instead of these three in series, I'm going to replace them with one equivalent resistor I'm going to call R2, 3, 4. So R1 is the same, R5 is the same, and this one, R6, is the same. Now, how do I find R234? I know R234 is by adding these in series. So R234 is equal to R2 plus R3 plus R4. So R234 is equal to 3 ohms plus 10 ohms plus 5 ohms. So R234 is equal to 18 ohms. So this is equal to 18. Okay, so I have my current coming out of the battery, IT. It's going through here. When it gets to this point, it splits between these two. So these two are in parallel with one another, because when it comes back here, it meets back up. So now I'm going to add these two resistors in parallel. So to add resistors in parallel, 1 over R, and I'm going to call that 2, 3, 4, 6, is equal to 1 over R6 plus 1 over R2, 3, 4. So that's equal to 1 over 6 plus 1 over 18. So to make sure I don't make a mistake and not do all this stuff on my calculator, I can easily find the common denominator between these numbers. So the common denominator would be 18. So it's going to be 318 plus 118, which is 4/18, which reduces to 2/9. So 1 over R2, 3, 4, 6 is equal to 2/9. So now I'm going to cross multiply. So R2, 3, 4, 6 is equal to 9/2, which is 4.5. So now I'm going to redraw this. R1. Instead of these two in parallel, I'm going to replace that with a resistor I'm going to call R2, 3, 4, 6, which is 4.5 ohms, and then R5 is equal to 0.5 ohms. So now when I look at this, I have my here's my battery. The total current is going through here, here, and here. What's the relationship between these three? They're in series. How do I add resistors in series? I just add them. So R 1, 2, 3, 4, 5, 6, which it'll just be easier to call it RT, is equal to R1 plus R2, 3, 4, 6 plus R5. So RT is equal to R1, which is 1, plus R2, 3, 4, 5, 2, 3, 4, 6, which is 4.5, plus R5, which is 0.5. So RT is equal to 6 ohms. And if I drew that, it would just be one resistor, RT, which is 6 ohms. Now, they don't give us the the total voltage of the battery. So what we need to do for this problem is we have to go back to here and use this information. Alright, so going back to this diagram, they gave us V3. So I calculated the current going through here. I3 was 3 amps. If this was 3 amps, because they're in series, this was 3 amps. Now remember, to find the equivalent, to find the voltage going through 3 in series, I would add them up. So what I can do is I can add up and say that V2 through 4 is equal to V3. Yeah, but I think there's an easier way to do this. You know what? We're going to do it an easier way. I can check my work that way. What we can do is, okay, these three are in series, right? In series, the current is the same. So if the current going through these 3 amps, that means this one that I add up in series, that means the current going through here is all 3 amps. So I can find the voltage here and say V is equal to IR, and I can say 3 times 18 is equal to 54. So the voltage drop here is 54. Now, going back to this diagram, you need to notice how I found the voltage drop here. How does the voltages, what's the equation for voltage in series? The voltage in series adds up. So if this is 54, shouldn't this plus this be 54? So what I can do is check my work. So 30 plus 15 is 35, plus 9 is 54. So I was originally just going to add those up to get 54. So either way you do it, whichever way you don't do it, use the other, check your work. So here I found 54, but that you thought to do it this way, you can see this is 54 there. All right, this resistor and this resistor, what relationship is parallel? What is same in parallel? Voltage. So this is 54 volts. That means it's 50. Now, if this is 50, so if I have R and V, what can I find? I. So I is equal to V over R. So 54 divided by 6 is what? 50 divided by 6 is equal to. So the current going here is 9 amps. Now the relationship between resistors in parallel is the current adds up. So the total current is going through here. I see that 9 amps is going down here, and I see 3 amps is going down here. So what that means is 9 plus 3 has to add up to my total current, which would be 12. So now I can see that IT is equal to 12 amps. Now I see going through this resistor is the total. So this means that I5 is equal to 12 amps, and I see that I1 is equal to 12 amps. So now if I wanted to, I could find the voltage across the first resistor and say V1 is equal to I1 R1. So it would be 12 amps times 1 ohm, which would be 12 volts. I could find V5 is equal to I5 times R5, which would be 12 amps times 0.5 ohms, which would be 6 volts. You know, every time I do this problem, I could do it a little bit differently. And I think I found everything I was supposed to find in this problem. I found the current and the voltage drop across each resistor. The thing is, when you look at problem, you know your chart. So even though we're going to have, so we have to know series and we need to parallel. And again, we need to know the relationship between resistance. So we know in series they add up. In parallel, it's the reciprocal. The current, I, in series, it's the same. So knowing what is the same and equal, this is the key to solving combination circuits, because it kind of helps you with what to do. We know that in parallel, And we know that both, which is the potential difference, in series it adds up, and in parallel it's the same. So we had a problem when we looked at the resistor and we used our intermediate schematic diagrams. We looked at the relationships and what were the same. So again, the current came through here, then it split. But again, it's kind of like operations. These two are not in parallel because these other resistors are in between. But these three, because they have the same current, first I add these three and I get the equivalent resistor here. Because the current's dividing between these two branches, and the current obviously is not always going to be even because the resistors are going to be different, but these two are in parallel. So then once I add these two in parallel, I find an equivalent resistor, and then I get these three in series. So this is the way that we work the problems. But again, the key here is once you recognize what is in series or parallel, you say to yourself, what's the same? So that's why when I was up here and they told me the voltage drop across this third resistor, once I have two things, I had the resistance and voltage, I can find the current, and because these are in current the same here, this is 3 amps, this is 3 amps, and this is 2 amps. Then I found the voltage drop across this resistor, or I could have added up these voltages. Either way, it's the same thing. I know that these two are in parallel. What's the same in parallel? Voltage. And that's how you do these types of problems. Okay? There's no shortcuts. You have to draw your intermediate schematic diagrams. If you don't draw your intermediate schematic diagrams, obviously you can't do that. Okay?